The next section is about the geometric figure called the kite. The name of the kite comes from the shape of the standard kite shown in this picture. It is a shape with diagonals that intersect, and it has that four-sided shape. This is the beginning of a portion where we're going to be looking at quadrilaterals pretty intensely. So we're really focusing now on the kinds of polygons that have four sides. The first property of a kite, and this is in your notes packet, you want to add this information. The definition of a kite is they have two pairs of congruent sides. They are adjacent sides. So BC and CD in this diagram are congruent, and BA and AD are congruent. They're next to each other. Not all of the adjacent sides are congruent, but there are two pairs of them that are congruent. There's also one pair of congruent angles. Those are the angles that are going to be opposite each other, and you can use the symmetry of the kite. There's a line of symmetry down the middle of the kite, and that can help you find these congruent pairs. So this triangle and this triangle are congruent, so their corresponding parts would also be congruent. So that's the first property. Make sure those are in your notes. The second property of a kite is that the diagonals of a kite are perpendicular. And before I get you too confused, a diagonal is going to be a line segment that joins opposite vertexes or vertices of our quadrilateral. The diagonals of a kite form right angles, and if you've ever flown a kite, you know that there's that crossbar, and then there's also a crossbar that goes from the top to the bottom, and they form right angles. The third property, and this is also something if you've ever made a kite or flown a kite that you probably are not surprised by, the longer diagonal bisects the shorter one. So this line, this distance from this vertex to the center and then from the center to the other vertex are going to be identical because the longer diagonal, this one, cuts the shorter diagonal into two congruent line segments or bisects it. And then the last property is that the longer diagonal bisects the angles. So if I draw that longer diagonal in, I know that it's going to bisect this angle, and it will also bisect this angle. So it forms a bunch of congruent angles, that longer diagonal. So given those four properties, we can mark some congruent segments and angles on a kite diagram. This is at the bottom of your notes. We have, according to the first property, we have congruent sides. These sides are congruent because they are adjacent sides and they're opposite each other on that triangle. And then also these, so those are the two pairs of sides that are congruent. And then we also have congruent angles that are opposite each other on the kite. So this angle and this angle will be congruent. So that's all from that first property. Then we know that the diagonals are perpendicular, which means that we know that these angles are right angles. So that's our second property, perpendicular diagonals. Okay, something else we know is that our longer diagonal bisects our shorter diagonal. So we know that these two line segments are congruent. And there's one more thing we know. We know that the long diagonal bisects the angles. So it gives us a lot of congruences. Knowing that we have a kite, if we draw those diagonals in, we just get a lot of things that are congruent. So if I practice this, I'm going to go through and say, well, angle 1, well, I know angle 1 and angle 40 have to be congruent because the long diagonal bisects those angles. I know that angle 2 has to be a right angle because the diagonals are perpendicular. I know, based on that, I know that I can find this angle. This angle is going to be 180. I'm looking at this triangle right here. I've got 180 minus 90 minus 40, or 50. So I know this angle is 50. And since I know that this angle is 70, I know that this angle is going to be 70 as well. So that tells me that angle 3 is going to be 70. Angle 4 is going to be 50 because it's going to be the same size as that other 50 that I marked. And then I can look at this triangle. This is a right angle because the diagonals are perpendicular. So 90 plus 70 is 160. So angle 5 is going to be 180 minus 160, or 20. Angle ABC is going to be 50 plus 70. And angle DCB, well, that's going to be angle 5 but doubled because of that angle bisector. So angle 5 was 20, so DCB is going to be 40. Okay, it's a lot of properties, but don't try to keep them all straight. Refer to your notes as you're doing this. All right. For number 2, I'm going to try to solve for x and y. I'm going to use these properties. Diagonals are perpendicular. The long diagonal bisects angles. So that tells me that this is 41. And so now I'm going to highlight for a second. This triangle has to add up to 180, so I'm going to use that to solve for x. So 41 plus 90 plus 4x minus 3 equals 180. 41 plus 90 minus 3, so that's going to be 128 plus 4x equals 180. Can subtract 128 and I get 52. So 4x equals 52, and divide by 4, so x equals 13. Okay. Now I'm going to highlight a different triangle. This triangle also has to add up to 180 degrees. So if this is 90, which I know it's 90 because the diagonals are perpendicular, so 90 plus 59 is 149, and then 180 minus 149 will give me the angle y. So So y equals 31. Okay. This example, we're finding the measure of angle A and the measure of angle B. I know that this angle and this angle are the opposite angles on the kite that are going to be congruent to each other. So that angle A is 146. And this is a four-sided quadrilateral. So I know that the sum of the angles is going to be 180 times 4 minus 2, or 360. I already have three of the angles. I have 146 plus 146 plus 47. I have 339 plus this missing angle is equal to 360. So if I do 360 minus 339, I get that this angle is 21 degrees. All right. These are some more problem solving with kite properties. So I'm going to start these, but I'm not necessarily going to finish them. This side and this side would be congruent to each other, so that's how I would solve for y. 11y minus 22 is going to be the same length as 7y minus 6. Then we would algebraically solve for y. I also know that this side and this side are congruent, so 5x has to be equal to 3x plus 12. I can use that fact to solve for x and y. Once I know x and y, I can use that information to find the perimeter. Okay. For number 5, I would start with that diagonal is bisected, so I know that 5x minus 15 has to equal 2x plus 3. So 3x minus 15 equals 3. So 3x equals 18, x equals 6. So that means that this diagonal is 15 and 15. Then we also want to find the value for y. We know that this side is going to be 3y and this side is going to be 2y minus 2. We also know the perimeter is 86, so if I add up all of the outside edges of this quadrilateral, I should get 86. So I'm going to go ahead and add those up. I have 3y plus 2y minus 2 plus 2y minus 2 equals 86. And then you would algebraically solve for y. Okay, I'm going to leave the rest as problem solving for you. I have my worked out solutions posted on Schoology as well. Please make sure you take a look at the way these properties are described in your note sheet on the back of your packet, because that's how you will see them when you take your test and quiz. Thank you.